Seasons of Earth. The moon was a result of a giant impact where the newly formed Earth collided with a Mars-sized planet named Theia. The giant impact blasted the material into space. Theia joined the newly formed Earth, which was going through the iron catastrophe. Thus, the material of Theia melted and combined with Earth, making it larger. The material that was blasted into space orbited, collided, and came together for a whole century until it formed the moon.
The gravitational attraction between Earth and the moon also stabilized the tilt of the Earth's axis, and it is today's constant tilt of 23.5 degrees that gives Earth its predictable, fairly constant climate and its seasons. Without the moon, however, the axis would have continued to wobble, as those that of the moonless planet Mars. When Theia first collided with the newly formed Earth, the Earth experienced days as short as 5 hours due to the giant impact. Even until today, the moon's gravity pulls the Earth. When this happens, the Earth's rotation slows down. Thus, the 5 hours has been increased to 24 hours. The energy that Earth loses is picked up by the moon. This means that the moon gets further away from the sun. Also, Earth's gravity stretched the moon into an odd shape.
The angle significantly changes the distribution of sunlight because when the angle changes on the same surface, the area it covers changes with it. This example shows if there's a sunbeam that covered 1 mile from a direct 90 degrees angle, the same sunbeam would cover double the area if it came from a 30 degrees angle. This means that the distribution would be much more spread out in 2 miles of the 30 degrees sunbeam, and the distribution would be more compact in the direct impact of 90 degrees sunbeam. On Earth, the southern hemisphere has the more dense and compact sunbeams during winter, while on the northern hemisphere has less dense and more distributed sunbeams. The opposite is in summer. The sunbeams are more distributed for the southern hemisphere and compact sunbeams in the northern hemisphere.
During May, June, and July, the northern hemisphere is exposed to more direct sunlight because the northern hemisphere faces the sun. The same is true of the southern hemisphere in November, December, and January. This difference in the intensity of the sun makes one hemisphere hotter, while it cools down the other hemisphere. During the months March, April, August, September, and October, both hemispheres get similar amounts of sunbeams, making the temperature of both hemispheres similar.
When the northern hemisphere is towards the sun, the season is summer. When the Earth is farthest away from the sun, this is also known as the summer solstice. Summer solstice is when the Earth's northern axis is tilted towards the sun. However, the southern hemisphere tilts away from the sun. This means that the season winter is in the southern hemisphere. This is also known as the winter solstice, and this is when the Earth's northern axis is tilted away from the sun.